Hello everyone, welcome to the explanation of my machine learning project titled Disease Prediction Model. So, this is the second assignment I received as the part of Mentorness machine learning internship. So, today's agenda is to cover how I analyze the dataset, its pre-processing, model building, metrics evaluation, the ROC curve, and why I chose Gaussian NB. Before moving into the technical side, we would like to know as the first step how we are going to analyze the data. Initially, the objective of this project was to predict whether a patient is diseased or healthy based on various medical features or attributes. So we were given with a data set, both training as well as test data set that contain multiple health related attributes such as cholesterols, blood cell counts, hormone levels, and other psychological measurements. So the dataset also included information on whether the individual has been diagnosed with a specific disease or not. So initially the libraries were imported such as pandas, which was used for data manipulation, scikit-learn, which was a machine learning library for Python, standard scaler for data pre-processing, and the metrics which were used to evaluate the performance of the classification model. The next step was data pre-processing, where we loaded the data from the CSV files using the pandas data frame. Then we drop the rows with missing values or null values which ensure the quality of data set, because on dropping the data set is complete and no calculations are based on incomplete data which could bias the results. The next step was the main step, which was model training and building, and the first step was to split the features and the target variable. So we separated the features x and our target variable y for both the training as well as the testing data set. And then we standardized the features to have a mean of 0 and a variance of 1, which was a requirement for the Gaussian Bayes theorem, or the algorithm which we were using to develop the model. Then we converted to binary classification, 0 for healthy and 1 for other diseases, since we had a multi-class problem, because people with several diseases such as diabetes, pressure, sugar, etc. were dropped down under the category of disease. Now the third one, we trained the model using the Gaussian Bayes model using the training data set. On testing the model on the test data set, we could evaluate the model's metrics based on accuracy, which measured the overall correctness of the model to be 94%, precision, which measured the correctness of the positive prediction to be 99%, recall, which measured the ability of the model to capture all the positive instances to be 95%, and the last F1 score, which was a harmonic mean of precision and recall, to be a 97%. Moving on to the ROC curve. The ROC curve showed a good balance between the true positive rate and the false positive rate, and we obtained a AUC score of 0.83, which indicated the model had a strong ability to distinguish between diseased as well as non-diseased individuals, and it also suggested that the model is performing well with high probability that it will correctly classify a randomly chosen positive instance over a randomly chosen negative instance. Why Gaussian Bayes for medical data sets? Because of three reasons: that it's suitable for medical data because medical data sets involve distributed features. Second is the efficiency, because Bayes classifiers are fast and require only less training data, which makes them suitable for large data sets with many features. The last reason is the performance, because despite its simplicity, Gaussian Bayes can provide good performance for binary classification tasks, especially when the assumption of a feature independence holds approximately true. Thank you. That's all for today's presentation.